Good afternoon, everyone, and thank you for joining us today for SME's Smart Manufacturing Experience webinar, What It Takes to Deploy Machine Learning in Manufacturing. Today's webinar will be a bit different. It's going to consist of a panel discussion revolving around the multi-year journey industry experts have experienced while implementing advanced data analysis and machine learning. They'll discuss for smart manufacturing, and thanks for joining us today. Really quick, a few housekeeping items to take care of before we get into the panel discussion. We recommend Google Chrome as our preferred browser. It's usually more reliable from our experience. You will have time to address your technical questions with our panelists, and you can do so by using the Q&A box on your platform. And you may have already noticed that your microphones have automatically been muted. And if you have any questions or technical issues, you can use the chat feature. We'll be monitoring both the QA and chat. And in the event of any technical glitches, we are recording this webinar and we will make it available on our Smart Manufacturing website shortly after our event. Moderating today's webinar is Paul Boris, President and COO of Premo. Paul has been driving digital transformation within industrial operations globally for decades. He's been an operations leader, a manufacturing thought leader at SAP, and a CIO of advanced manufacturing strategy at GE. He has the ability to simplify the complex technology landscape and adoption cycle to deliver sustainable results. In his spare time, he advises startups in the advanced robotics and machine learning and AI space. Joining Paul this afternoon is Matthew Krug, postdoctoral research fellow and lab manager at Clemson University, and also Andy Henderson, chief technology officer at Premo. Thank you, folks, for supporting today's webinar. And without any more delay, I'll give the floor to Paul.
Thanks, Carl, and I appreciate everybody joining us today. As Carl mentioned, we've got the Q&A feature working. If you've got questions, feed them in as we're having a conversation. We'd like this to be more conversational. We will take maybe a couple minutes at the end and answer some questions as well. So don't hesitate, and I'll be watching that. You'll see me glance to the side on occasion just to pick up some of those questions as we go along.
Right.
I have to tell you, though, it's kind of an honor here. I've known Andy Henderson for quite a few years now. We worked together at GE. He was a real thought leader in the organization in the Greenville power operations down there. That's the first place that we met. And we have the pleasure of working together now at Premo. And when I was visiting South Carolina, I got a chance to meet Matthew at the Clemson Vehicle Assembly Center. And he's now, his part-time job, I guess, he manages that lab as well. He's got a really keen mind on looking at sustainability and capability within complex operations like vehicle assembly. And if you've not been to that lab, Matthew, I don't know if you invite people down to visit, but that's just an amazing place to see it with some of the projects going on. So we've got the right folks here to talk about this. We're going to have a real practical component of this, as well as a heavy research-focused component solving big problems that haven't been solved in industry so far. So yeah, I gave a little bit of background, but maybe we could start with you, Matthew. If you could just take a second and talk about really where you are on this topic and why you've got some insights that people might want to pay attention to, take some notes with.
Yes, thank you, Paul. I come from a number of years of working with many different manufacturers around how they can implement technology on the factory floor, and especially in the assembly space, because we're slowly moving and adding more digitalization to the manufacturing shop floor, as well as we're having new requirements for being more flexible in our production. And so that's really what we have seen a lot of at Clemson University is this transition to from the small and medium enterprises are now not in competition with the larger enterprises for this digital content, they're all working together towards these common goals to have a more connected shop floor, as well as to be able to use these tools more readily and more easily. Because the same problems that a large corporation has are similar problems that the small and medium enterprises have as well, and that we're targeting to solve with technology. And so what our center has done a lot of is helped to guide some of the fundamental research. So more of the big questions of we don't really know where or how to ask these questions yet. And that's really where we come into play and have had a very good relationship with many companies.
I mean, that's got to be a great spot to be in, because if you're in industry, or if you're servicing these industrial organizations, you keep things closed a little bit. Sometimes you've got that opportunity to have these conversations across organizations that might, well, you said it yourself, they're really not competing with each other anymore. They're trying to figure out how to collaborate, because the OEM wants the suppliers to have the best technology and take advantage of it, and they want to really be able to learn from those folks.
Mm-hmm.
Is that really how it lines
exactly.
up?
And that's exactly how we've lined our center as well. So our center is based on providing a production simulation. We can have the needs and infrastructure of a production line, but without the production pressure and need to produce units. And that's really where we get to play in this almost a playground type area, where we can trial these new technologies, as well as try out different things that may or may not work in the real world just quite yet.
Yeah, that was, I got a comment on that. I've worked with the Clemson group that Matthew's a part of for, I don't know, 15 years or more, I guess, a while. And that's always, when I was at GE, one of the great things about partnering up with the center at Clemson is that they had all of the equipment that you would need to do testing offline, so that you weren't disrupting production to run experiments and answer questions and figure out new information on how to process, how to do the manufacturing operation part of it.
Yeah, Andy, I remember, meeting and going to Bojangles at 5 a.m. for, breakfast, talking about this stuff, and then heading over to the plant in Greenville. You're in it's a completely different, I think, and tell me what I'm missing. It's a completely different mindset, because you do have the pressures of production, and you do want to do the experimentation, but experimentation is important, but not critical. Production is critical, and you balance these things. Maybe just talk for a second, like Matthew did, around, why you've got an insight in this space that's probably beneficial.
Well, to kind of just keep going on the thread that you were on there, Paul, about how you don't have in a plant, you don't have the luxury of being able to stop and run an experiment and try something new. That was doing that work with Clemson and trying to move whatever we learned into the plant was sometimes tricky, and because it doesn't always translate from a lab test environment into a real manufacturing environment, which, getting on this topic that we're on today, that was a big driver for doing a lot of data and collection inside of the plant at GE, was to be able to say there's a lot of natural experiments almost that happen on the shop floor. And so if we can capture that data and learn something from those natural experiments, those small perturbations that are giving us different outcomes, then we should be able to learn a lot even from what's going on inside the four walls of the plant. And then you can combine that with the fundamental pieces that you learn by doing the testing offline and all those experiments, and that's when you can really grow in your manufacturing understanding and capabilities.
So you guys are going to be at SMX in Pittsburgh here in a few weeks, and I know Carl's going to talk about that later. And you're going to do a session on this stuff. But Andy, you've got the urgent physical world manufacturing driving product, and one of the questions, Matthew, was are you just a physical space or a digital space? You've got both there,
Mhm.
really. I mean, you're trying to mimic
Yes.
what Andy's doing, but without, like you said, that pressure of production.
Exactly. So we have both. It's primarily a physical space where we can bring in sensors, equipment, and trial different systems. We're actually about to implement 4 different vendor systems in our lab so that we can trial and see which one is better for the application of an end user. And so, but to mimic that, the real world as well, is we also have to have a digital aspect, a digital twin of our existing center, because that's readily becoming a very important aspect for companies to start considering. Is what is your digital footprint of your factory and your manufacturing plant going to look like? And so we also would like to be a center not just for the physical prototyping, but also for the digital prototyping as well.
Yeah, and I'll I love this conversation because my so my career started. I got a little more seniority than maybe most of the folks on the call, but I started way back in manufacturing and operations, running manufacturing and operations, moving into the technology space, and I've seen, you see this evolution of the technologies and the practices and the processes and all these kind of things. And there's I don't know who said it. I don't remember who said it. I'm sure somebody else said it. I didn't come up with it first, but if you're an athlete on the field, after you get enough reps in, things start to slow down. The plays start to slow down around you, and you start to see how they work. And that's kind of where I sit at this point, even with my role at GE and how I got in touch with Andy and then ultimately Matthew a few years back. It was, it's amazing the natural, that's a great term, Andy, natural experimentation that goes on, whether or not people realize these are natural experiments. And because of, in a disciplined operation or certain manufacturing operations, there's a focus on accumulating the appropriate data down at the operational level, at the machine interface, right? And we'll talk about this and we'll expand on this a little bit more as we go, but no one running a plasma coating booth is necessarily thinking about the ramifications of that data and how it impacts kind of the field service of that device. However, it does. It just, there's some complications at it, but they're going to ensure that those systems and that data is tuned for the purpose that it's applied, right? For running that operation, for making sure things don't crash into it, and it's not putting bad parts out from the operation. So, I've seen this data forever. I've seen it in these pockets at the operation. Now, folks like Amazon and Microsoft and Google have given us the ability. I mean, you can pick up your iPhone and spin up an Azure instance now and start accumulating data and running some of these tools and models against it. To me, it's a really obvious choice of why to deploy things like machine learning in the first place. But let's start there. Maybe let's talk about why this is even a valid consideration. I'll pop up a slide in a minute, but I'm going to let you guys go first and talk about it. Andy, do you want to jump in on that one?
Yeah, so the question is, what are the benefits of using, why bother deploying these technologies, ML?
Yeah, why bother? And if you recall some of the benefits that you've seen specifically in taking this approach.
Yeah, so one response is there's just too much data for people to continue combing through, and that we have to apply tools like this in order to be able to comb through all the data that's there and pull out those interesting pieces of information. And then, to expound a bit upon that, there are numerous different, say, products, right? And maybe each product behaves a little differently. And so the reason for the learning system is to be able to learn those differences from one product to the next and be able to understand how to handle this particular data point in context of that particular product without a person having to go manually set that up. And then, maybe it was ingrained in me at some point. I love talking about dollars and those kinds of impacts of machine learning. And we've seen uh, uh, applying these machine learning to being able to prevent escaping defects to the tune of preventing multi-million dollar issues from occurring, from getting outside of the factory and then having to respond when the customer says we've got a problem with the products that you supply. So machine learning, we've been able to deploy it there and been able to avoid escaping defects. Also, machine learning being able to say there's identify at the onset of a low productivity point. So the system may be responding as it's currently set up to, but it's not currently set up properly. And so therefore it's responding in such a way, and it's actually slowing productivity down on the floor, but it's not raising its own alarms just because it hasn't been set up to. And the machine learning piece has learned from the history to say what's expected, and then it gets to that point where the manufacturing operation isn't behaving the same, and it's able to raise that so that the period of slow productivity doesn't keep going. I feel like I probably butchered that last bit, but
well, you started it the right way. It starts with the dollars and cents, and it's either a mitigation of an escape or making sure you're getting the right throughput, right?
Yeah. Yes, costs, manufacturing cost, and increasing throughput, productivity, for sure. Matthew, you like your...
Yeah, I think that also gets into a little bit of the area that we see and we get asked for around machine learning a lot is around transparency of the processes, and what is the actual status of the plant right here, right now. And we can put a bunch of sensors up. We're very good at that here at Clemson, and most manufacturers are very, very good at that. But how do you monitor that? And I think that's what you were really getting into, is how do you monitor all of those data streams that are now coming available without overwhelming your workforce or having to hire an entire team of people to analyze and watch over this data?
So, I have some slides, and we didn't want to turn this into like kind of a PowerPoint session, but picture's worth 1,000 words. So Ricky, if you could pop up slide number 1 there on the productivity plateau, and what we're looking at here is, so this is from St. Louis Fed. It's great. There's great data at this site. If you look to the right, this pushing the boundaries of minds and machines. I got a chance to meet and become friends with Marco Annunziata. He was the chief economist at GE at the time. They had great conversations around this. But in the 2012 timeframe, they wrote the paper that kind of introduced the concept of the industrial Internet of Things. The Internet of Things was coined around 2000 timeframe. I started in manufacturing off the left side of this chart to give you a sense of my time domain on this. And it's pretty staggering to me that, and this goes back to the natural experiments, right? We started linking PLCs to PCs, right? Clearly, there's got to be something I could do to make the data flow simpler. And then the World Wide Web emerges, and then Internet of Things, OPC UA, these standards that are pretty durable that have hit. We started dropping the price of sensors, and we got into this really troubling. I call it the productivity plateau. It's been this way for over a decade, and I think the primary reason to deploy machine learning is that the continuous improvement teams are now, and look, I'm not picking on anybody, and if I insult anybody, I apologize. I'm not intending to do that in any way. But we're actually stacking sensors on top of sensors. We work with companies where they say, I've got a device, and that device has a whole array of sensors and a lot of data in it. It's just so tough to get at, and it's so tough to harmonize and aggregate. I'm actually going to take a lick'em stickum sensor and put it right on top. I'm going to take a production filling line and I'm going to bolt a vibration sensor up to the side of the motors, or I'm going to put a device that gives me all kind of telematic data from a mining haul truck or something like that. And you take that in combination with what's going on at the top of the enterprise, where we say, let's build a large, complicated data science practice whose purpose is to vacuum up all of this data from operations and harmonize it so that we could start to apply these tools to it. And I think there's a different way. Well, we've that's why we started a company, because there is a different way to approach this down at the operation. But all of that data, and Andy, you said there's actually too much data that you can't comb through it. Humans aren't able to go through this. And Matthew, in the research sense, you may not see it as much because you don't have the volumes and the time domain associated with production. But this has to be defeated. This productivity plateau has to be defeated. We have to figure out how to get that curve going back up to the right at a 45 or close to a 45. And I think it's going to come from interrogating the data, the lowest level underlying data that companies have. And you could drop this now, Ricky, thanks, that they have, because when we've done that, Andy mentioned a couple, and it has been, without exaggeration, every single customer we've ever interacted with received value from it, up to and including a great company out of Ohio that does flat pack furniture that had a problem, what they thought was a problem, that we were able to show them with the data and machine learning that wasn't their problem. Their problem was something else that they should focus on. And you can imagine a manufacturing enterprise saying, we're going to spend a lot of money on censoring things. We're going to spend a lot of money on accumulating data. We're going to spend a lot of money on strategy so that we can get this right and execute. We're going to build new machines because we don't have the capability to hold the tolerances. And we found this time after time after time. You can learn those things from the data and maybe avert expense and improve performance pretty quickly, cut lead times. We've got the one customer that he tells folks he cut his lead time by 50% because his lean team was better enabled and didn't have to comb through the data in the DMAIC wheel, right? The analyze piece was done by the machine, and it could point the people in the right direction to actually get some of these things done. So, before we move off kind of this idea of benefits, you guys, anything else that we missed that we want to touch on?
A little bit. That's actually another. You brought up a point at the end there about learning some new insights from that data. That's also another area that we've seen benefits, as well as that. For years we've been collecting data, and now we can actually start to really mine that data and look into the trends that exist in the historical data that we've collected, as well as that we could have in the future. And that has helped us as well to find issues that some manufacturers didn't even know existed, as well as determine root causes that have plagued particular product lines or individual stations for years in the past. And we've never been able to, and just through standard root cause analysis, we've never been able to find it. But with access to that data, we were able to find and learn new things about the processes. Even looking into
these people that you're teaming up with it's not because they're not educated or dedicated or working hard or whatever, right? You find new things because the tools they have aren't suited to find those things, right?
As well as we bring a different time aspect. So they have production pressures again, and that gets back to they have production pressures that they're under. They don't really have the time to always to go in and look at these other tools that may or may not have value initially, but then in the long term you start to see the benefits of them once you learn more about how to apply them, and you also work with people like ourselves at Clemson or Primo as well, of how you can deploy these tools and learn that and bring that information and learning back to you from just pure data.
Yeah, so I'm just going to do two things, and Andy, don't lose your train of thought. I'm going to remind folks, if you got questions, we're trying to feed them in live as we go. So put them into the Q&A, and we might take a couple minutes if we have at the end. So go ahead, Andy.
So Matthew actually raised a question on my end that I want to ask. So what do you guys have any examples of what's the most interesting benefit that you weren't expecting that you actually saw? Do you,
hmm So we were actually able to find from one application where we deployed some semi-intelligent cameras. I affectionately call them my dumb cameras because they're not quite the same as what you find with a key answer or Cognic, the intelligence and part detection. But those are very purposeful and very powerful tools, but they're devoted to a very small and dedicated task. And we were able to deploy some camera systems with a more generalized application to look at uh, quickly be able to put these out onto the factory floor of where we had complaints from workers on the factory floor of a defect in a particular area. We were able to take these images that were coming from these cameras and go back through them and figure out where were these problems really coming from. And to do this from a person perspective, you would have to review hundreds and hundreds of images per day. We're talking maybe about 1,500 to 2,000 images per day that would have to be reviewed manually by a person. And then we were able to quickly write a script that looked through all of this information for us and gave us descriptive statistics that allowed us to find out that purely because, in this case, it was a miscommunication between quality teams in different areas of the plant. And the quality team in the upstream area had made a change that had an effect in the quality area of the team in the B area, but they didn't know that change was having that effect. And so being able to find that they were able to find that a problem actually did exist. It wasn't just the associates saying that this is a problem, but then not having the time to write things down and document that something had actually occurred, to try to document the case and the scenario and all of the information and details that are needed for a quality engineer to do their root cause analysis. We were able to quickly gather that through machine learning and provide that to the quality engineers, who were able to very quickly diagnose and say, okay, we know exactly where this is coming from now that we have this information. It was about generating that information.
Yeah, it's a pretty powerful story, because you wish it were different in a manufacturing environment, but you walk past these issues and the evidence of these issues, but the attention is drawn somewhere else, or the urgency is drawn somewhere else, and you just don't have time to drill into them.
well, I remember an example. I remember an example where some data was being captured about PPE that was being consumed. So it was coming from a vending machine. So we had data about the amount of PPE that was being consumed, and there was an anomalous spike in the cost of in these gloves that were being used, and it was because a different type of glove was put into the machine, and the person who was pulling the gloves out was pulling them out every day and didn't realize that they were these drastically more expensive gloves.
Reusable, yeah.
Yeah, and so the way to address that is just communication. It's just information to say, hey, these are actually different and these are more expensive. You should try to reuse these. And so, but it was that piece of insight that came out of data from the vending machines about PPE.
Mm-hmm. That's a very common error we've seen, is unintentional changes from minor things that seem minor, or putting a different type of glove in the vending machine that it seems minor, but it actually has a significant impact, or could have a significant impact.
Yeah. In the old days, 100 years ago, I talk about your pattern matching algorithm at the brainstem. How the most senior folks in the operation used to be able to sense. I mean, you do your walk around and you understand these things. And I remember the first plant that I ran a long time ago. The rule was when the owner walked around and lifted up his audio recorder to his face, the first thing anybody did was get over, stand in that spot, look where he was looking, and figure out what it was that he saw and what he was recording, come up with a premise of what he's recording, fix it, call me. So when I sat down for my Monday, my first day meeting, he'd say, hey, that heat of metal back in the, at pillar C20, I go, yeah, no, we know about that. They were waiting for that to get sparked. There was a quality issue. It's back up, and we got the heat tag on it. So okay, right. So this is just normal human behavior. It's what a parent does when they see a child that's not feeling well, and they detect these patterns, but it's at a rate and a level of impact that's much faster, much higher. I actually talked with the dean at Tufts. At Tufts, he wrote an article about how poorly AI did in the pandemic, except for very, very specific use cases, and it was a big disappointment. And the way he described it, I posted this on LinkedIn, sounded like it was manufacturing data. I actually took his post and crossed out, pandemic and put in quality, and these are problems that are not specific necessarily to manufacturing, but manufacturing exacerbates them because of the amount of data and all of these other systems that build up over time. And maybe it's a good segue into the hurdles. Like so if we think machine learning has got some potential and it's definitely going to bring value in almost any manufacturing environment in the ways that we talked about here. Matthew, you got some idea on the kind of the common hurdles, maybe the biggest hurdles to deploying these types of technology, and maybe Andy, if you get some thoughts as well.
Mm-hmm. Yeah, very, very common one that we find is learning to ask the right question with these. From my perspective in the research world, we tend to answer the questions that we don't quite know what the answers are. But one of the biggest hurdles, I think, first one, learning to ask what is your guiding question going to be for this particular deployment? You don't want to do machine learning for the sake of machine learning. You want a good solid reasoning of what you're doing. What is your return going to be, or what is your expected return from this application? Even if maybe it might not return actual costs, but it might return productivity or flexibility of your systems. And so that's one of the first areas that we always like to talk with the people that we're working with, is to really get a good understanding of what is the question that's guiding this deployment. And then we start to look at what are the capabilities of the team that we're working with. From the Clemson side, we have a very strong presence in machine learning and knowledge base in it. And that might not always be the case with the companies we work with. We work with individual, mom and pop shops, all the way up to larger corporations that have full data science teams. And so it's very different in how we'll approach it based off of which kind of group we're working with. And that can also be a very common kind of one of the scary factors of machine learning. And one of the very difficult things to get into is getting to how do I get the expertise, and how do I get that understanding of how do I take those first steps?
So Andy, what have you seen?
Yeah, I actually, so Matthew's first point about asking the right question, I think that's crucial, right? Understanding where is the need in the business. Is it that your quality yields from a particular operation are lower than they ought to be, than you want them to be, or is it because...
So hold, Andy, 1 second. So when you guys refer to the right question, you're not saying the right question being, is this machine the problem? You're saying the right question is, am I going to get more throughput or better, right?
And that's exactly my point. I was going to extend it to say you should have those questions or those problems you want to solve, but don't become too fixated on a thing, because one of the biggest hurdles on a specific way to solve that problem, because one of the biggest hurdles is the notion that I don't have the right kind of data. I have to go buy a new sensor to put on this machine in order to get the right kind of data to address this particular aspect of the problem that I'm having. Oftentimes, what we see, almost every time, what we see is that there is enough data available to start churning and processing through in order to address the problems statements that have been outlined. it's a throughput issue where we can, there are, any newer machine is likely going to have um, flags, states inside of the control that can be easily extracted out for the purposes of analyzing the cycle times and various events that drive that throughput to be able to determine when there's something odd going on that's causing a ripple effect throughout the entire value stream, the entire manufacturing process.
I remember that conversation with the customer where they said, "Hey, we've got this thing. It's not performing the way we expect it to perform. We've got some really good MES data on it, but we've poured through all that. There's nothing in there, Andy. We're going to put some sensors on. We'll see you guys in about 3-4 months." And it's always entertaining to be on the call with you and the customers because your experience and your credibility. And you were like, "Yeah, just give us the MES data." And they're like, "No, there's nothing in there." You're like, "Yeah, just give me the MES data." "No, there's nothing in there." You want to talk about what happened when you looked at the MES data?
Yeah, I mean, we found a preventable, if the system had been running, the AI engine had been running, it would have raised a flag at the onset of an issue that ultimately caused them to lose 75% of their productivity on the floor just by looking at, again, the bits of information that were being collected and stored after each iteration of each cycle of their operation. So I mean, and also that was another escaping defects. So it's because what it ultimately led to was the fact that there are control limits inside the automation system that are supposed to determine that the product, that when to stop the operation because the product has met its goal, or when to raise an error because it's not going to reach the objective, the goal. And those control limits, what the engine raised was odd behavior that happened because those control limits had been manually adjusted. They've been set at some unobtainable upper threshold. And so that's potentially an escaping defects issue as well, on top of the fact that you lost 75% productivity during that period.
Yeah, and my bubble slide, I think, is the one I like to go to. So Ricky, if you could pop up slide number 2. We've spent a lot of time deconstructing systems, physical systems, into their data elements, and then spent a lot of time deconstructing problems or views into applications, these digital elements. I think the success is the failure, right? That this is part of the hurdle. This slide's 14 years old at this point, and it's as true today as any other day. You can see where that pinches down to the upper right, really where the carpet and the concrete meet, the office systems. And if you look at the kind of the IT group, there's a distinctly smaller set of bubbles there, right? They've got large systems called ERP or financials or procurement, and sometimes that's all in one integrated system. But as you move down to the left of that, it's this explosion of systems that really are just a different manifestation of fundamentally what the customer wants on the upper right, but more likely all of the data that's being accumulated down on the lower left, where the machine, material, manpower interface meets. And we've over time built these complex array of data elements, systems, applications, everything in the operation. And the hurdle is people think the approaches are to say, data science team, let's harmonize all the data. And I talked to one very large manufacturer who's spent an amount of money that you would think I'm lying if I told you what it was on these types of things. And I said, when you're done harmonizing, pulling all of this data from your operation into this enterprise store, how much will you have? What percentage of the data will you have? And the answer was 50%. my question is always, which 50%? It's probably the 50% that's easy to get for the most part. It's not necessarily the 50% that's the most critical. And if you step back and you take a look at that approach and say, look, if I could find a way to kind of automate the data science of connecting into the array of systems and data repositories where they sit, get that lowest level data, and then apply machine learning to it, and then bring out these insights. It goes back to the examples you've given, Andy, around systems that already existed, data that already existed, processes that already existed, that when they get interrogated by machine learning, they cough up these insights, these answers, and everybody scratches their head and say, why does that happen? Okay, now we know what specifically to go and attack, how to fix it. And that engine can sit there and continue to listen and monitor and say, okay, we haven't backslid into this pattern of behavior. So this is kind of a natural landscape of manufacturing. It exists.
Yeah.
It's not good or bad. It's just the reality of it, right?
And so this is actually a good point to ask a question that came up a moment ago in the Q&A about do you use MT Connect to get that data out? And the answer is yes, but we also have to use many other methods to get data that we need, because as you can see Paul's landscape here, there's so many different systems that may not be providing data in a standard like MT Connect. And we love standards are great because you always know what to expect when you encounter them, but we also have to be capable of taking data from anything.
So Ricky, we can drop this slide. Thanks.
So that's also a common area that we've seen some companies struggle with is you have so many disparate data systems that may exist, especially from legacy hardware, that it can be hard to bring all of that together manually. That's also where it can be very good to use some of these structured approaches that exist under machine learning to bring that information together into one place, or at least be able to access all of those systems separately from one central area that's bringing them together and learning and generating information and knowledge from them.
Yeah.
And Matthew, you mentioned when we were talking the other day a little bit about kind of picking the right tool for the right job, right? Because this isn't, again, it's not picking on one approach or another. It's just saying if you take the wrong approach and you apply it in a suboptimal way, you're not going to get an effective result. Do you remember that part of the conversation? You want to touch on that a little bit? Yeah,
a little bit. So that gets into a little bit of the area of that we as researchers love, is that optimization of using the right tool for the right job is definitely going to be a very important part of any machine learning operation, and it can be very hard to make those decisions, especially if you're new to the space or don't have a lot of experience in it. It can be difficult to make a decision of which route do you want to go down to approach the question. So now you have let's say you have a solid question of what you're trying to do. How do you even start approaching that problem? And that can be difficult to go down these things like MT. You may hear buzzwords and from companies like MT Connect is we really love that for certain types of tooling and certain machines, but then it may not always work for all tooling and all machines, as well as it may not work for your custom application that you need. And that can be where partnering with someone like Primo or Clemson can also help to guide you down that path of where should you go and what tools should we maybe be looking at as we move down that path.
So Andy, a question came in and it said, using this for something like predictive health and machine maintenance, those types of things. And first of all, let me take my 30-second rant of, 5 years ago, we talked about reliability-centered maintenance and prescriptive maintenance, and now we're falling back to predict, right? It's supposed to be reactionary, predictive, and then reliability. Now the new thing is to go back to predictive, because reliability-centered, to me, was a death march, right? I mean, it was just it's very difficult. And you touched on this earlier when you talked about using machine learning, because it's not just this part but variants of this part, not just this part machine combination, but part machine material combinations. And when you look at a maintenance scenario, you would have to have, everybody wants to talk about digital twins. Everybody wants to talk about these types of things. There's some form of a digital twin out there, because if you're getting data, that's part of what the twin is. But the requirement to create plans for every class of machine, vintage class, maintenance team capability level, and so on, is impossible, right? So can you talk about how this gets applied, and the hurdles, right? Getting over these hurdles. One of the ways to get over the hurdles is to get started and to do something and to learn from this in a productive way. Can you kind of wrap that up in a little bit of an example? Do you have something in mind, Andy? Don't mean to put you on the spot.
So a hurdle of how to, or an example of how to overcome hurdles wrapped up with predictive maintenance. Is that?
Yeah, maybe start with a machine capability or machine performance predictive maintenance example. That's a quick win, quick start. Can you think of something?
Yeah, I mean, on the predictive health and maintenance side of things, I mean, that it dovetails into just about everything. I mean, you might have quality data and you think, well, that's quality data, but if there are, so as a machine degrades over time, there's typically a drift that occurs in the outputs of that machine. And those drifts that may occur would probably show up on the quality, the inspection that you do for quality purposes of the products. And so to answer the question of, do we use AI and ML for predictive machine health and maintenance? Yes, absolutely. And but it's not solely for that purpose, right? It's in some regards, it's kind of like a Swiss Army tool, because you might identify some or the AI agent might identify the drift pattern in quality, and then make an alert to let people know that you're going to have to make an adjustment in order to stay within process control and keep making good products. But if that drift continues or shows up in multiple measurements, multiple signals across an entire product, that could be an indication that the machine is degrading to a point where it needs to be addressed, and then that also resolves part of your quality issue. So I hope that helps address the question. The answer to the question is yes. In terms of a simple use case to getting over those hurdles, I think, to me, I love quality, because we as manufacturing, we tend to do a really good job of keeping records of quality, about the quality of our product. And so that's a really that's where you can tend to find a lot of good data with long history. And so go there as a starting point, start processing that data, and you're going to start uncovering process controls issues. You could even uncover throughput issues from that quality data. You'll start to uncover machine health issues from that data. I don't know, Paul, does that?
Yeah, that's exactly where I'm going, because these things feel like the domain of the research world with Matthew, or they feel like the domain of IT, corporate IT. And it just seems strange to me that the manufacturing team that generates all of the data sends it somewhere and then has to go write a 10-page report to ask to get the data back so that they can do something with it to impact the process, right? And I don't know, Matthew, I mean,
Mm-hmm.
do you see simple ways that people can kind of get started? I think just in manufacturing in general, but especially from your perspective on the research side.
So actually, one of the common things that we do when we when we first start working with a company is, especially when we're dealing with assembly type situations, we look at the start and the stop times of when did things happen. And that's one of the easiest ways that we've seen to look at and look for problems is, just as Andy mentions, things start to change over time. And there's some natural variation that occurs, and then there's also that unnatural variation that might indicate that defects are coming or have occurred, or maybe a machine is starting to degrade or break down. And so one of the first things we always like to look at is how is the process timing being affected currently? Are we within our norms or are we outside of those? I mean, sometimes even when we're within those process control limits, we may also see changes or shifts or subtle shifts in how the machine is performing over time. And that can really be a strong indicator for us early on that there's more happening at that time than we currently know about.
So I got an example on the one last slide, Ricky. If you want to bring up slide 3, look. I used to work for SAP. We would spend 18 months with a customer trying to convince them to spend $11 billion on something that was going to save them twice as much. And SAP is a great company and they do great things. I'm not making fun of SAP, but the reality is, as a manufacturer and as someone who's run operations, if you could take 18 months and save some huge amount, could we take 9 months and get an example, and maybe could we take 9 weeks or 9 days and actually understand exactly where things head? So one of the ways we start, and this is an example from an OEM, I put the not SPC symbol up there because this is not an SPC chart, and Andy can touch on that.
You're not saying SPC is bad. You're not saying
no. I'm not saying it's bad. I'm not saying SPC is bad. I'm not saying stay away from SPC. What this is we'll often go to a customer and the customer will say, I don't really know. I mean, this sounds interesting, but I don't really know what it would help me with, and what type of business case I can build around it. And we'll take historic data. We'll say, look, if you've got an area that's a concern that has problems, has gremlins, we can take a look at the data. We can process it through the analytic engine, through Razor, our product, and then we'll come back and we'll tell you some things about what we found. And so this is a forensic analysis. And if you look to the left side where the number 1 is, this is where machine learning has processed the data, and it's not smoothing the data. Andy corrected me. That's a bad term because that takes fidelity out and granularity out of the data. It's basically, I would frame it as kind of taking the noise out, things that are inconsequential, and listening for patterns of signals, multiple signals that have some sort of correlation that the human would probably never dig into. And the way this worked is we said, look, here's what we found. At this point number 2, there was a deviation from typical behavior on these systems, and this is an interference problem in a body shop. So there was a trend or a pattern emerging that indicated you were moving towards some sort of an interference, and that was triggered in the data a full 5 days before, at point 3, where the operational system said, I have a problem, pay attention, before the alarm sounded. And then what you see at point number 4 is where engineering intervened, right? We picked up another pattern, a change in the pattern. They said that's where engineering stepped out, took their best analysis, and tried to come up with a way to mitigate the problem. And the machine learning engine at that point is still listening to the data and says, well, whatever they did, it didn't impact the root of the issue. It didn't mitigate the problem. So had this been running, it would have flagged them earlier. It would have pointed them in a very specific direction. It would have said, look at these things because they're indicators of trending toward a failure, before that failure manifests itself in a quality problem or a downtime issue or throughput or whatever bad things could occur in a manufacturing setting. And this allows us to kind of hold up to the customer and say, here's the data you have. Here are things you missed when you looked at, when you were analyzing this data. Not because you're not paying attention, not because you're not working hard, they told us to the left side of this, they wouldn't even know why they would be spending time analyzing that data. It was not logical to the human mind, but the machine learning engine just pours through this and grinds through the data and comes up with these insights. The other thing that was really interesting is they said, when we find this, we're not even sure exactly how we would impact it, because I can't remember, Matthew, if you said it or Andy, you said it. These problems are kind of coming from different. You said it, Matthew, right? The problems are being. It was a fix in a different area that looked like a logical fix, but it caused a problem downstream, and we had a problem in a different area. So, Ricky, you can drop this. So that's an example of how to kind of clear hurdles and start quick. We've only got just a couple minutes left here, and I've been monitoring the questions coming in. If we could just kind of do a lightning round here, we'll start with you, Matthew, and then go to you, Andy. What would you say to somebody about the most effective way to get started, especially in support of trying to scale this out? Expect to be successful, so then you got to scale it up. You have some comments there?
Yes, one of the best ways that we've seen to get started is, one, form that guiding question of why are you doing, what are you trying to do, and what is the goal that you want to get out of it in the end. Not just an optimal process, but what is the actual metrics that you're trying to affect. And then move into inventorying what data is currently available, because we don't always have to add some processes like we discussed earlier. There's a lot of existing data. And sometimes even just plotting that data can be very powerful, just like the chart you just showed. Being able to plot that data and see that information. But eventually we get to a point where we can't plot enough, where we don't have enough people to plot all that data and look over those charts every single day. And that's really where the machine learning aspect can start to step in, and start to do that analysis continuously, as well as look for those deviations. And start small would be one of my biggest recommendations. Is looking at even just your process start-stop times. Look for those deviations that might be relating or showing up early on before any faults or defects occur. As well as if possible, keep good fault records. That's one of the most common ones. That's one of the things that has held us back most commonly is lack of detailed fault records.
It's surprising that people don't do better at that. So, Andy,
the amount of time it takes to fill all of those out, and making it a priority.
Yeah,
for sure.
So Matthew took a bunch of my thoughts. Like, start small. I'd say we get into analysis paralysis, where we want to analyze. We want to say, I don't want to pick a tool, or I don't want to pick a path until I've explored 10 different versions of it, and I've identified what's best for me. I mean, you need to do some of that stuff for education, but don't get bogged down in that stage. Get started. Figure out, like we've been talking about, where can you make an impact? What's that question that you want to answer? Get going with a data source and operation, maybe even a line, if that's the way your process is set up. Get going, learn something, and be ready and able to pivot if necessary. And pick up, the other piece here is to pick someone who's been down the path before, not just from a data science perspective, right? There's a lot of there's a lot of really sharp people who understand how to work with data and extract information or extract interesting things from data, but you want to work with someone who also has that engineering and that manufacturing experience that can help explain what it might all mean.
Yeah, the only thing I'd add to that, and we'll wrap it up here, is that you got to remember, it's not fail fast, it's fail fast, fall forward, right? You've got to be learning something from it, like you said, pivot and actually move the process forward. So this has been great. Matthew, thanks for the time. Andy, thanks for the time. To the SME team, great team. Ricky and Carl, you put together a great show. It's always a pleasure to work with you. Thank you so much. And folks really ought to come and see Andy and Matthew in the session they're presenting in Pittsburgh. It's going to be a great show in Pittsburgh. So Carl, I'll turn it over to you. Thank you.
Yeah. Thank you, Paul. Thank you, Andy and Matthew. Appreciate it. Special guest, very informative, great discussion. Special thanks to all of our guests for providing their insights into the opportunities and challenges deploying data analysis and machine learning in our manufacturing operations. We appreciate your time supporting the manufacturing community and SME events. And of course, a very special guest to all of our attendees who participated this afternoon. We appreciate your time and hope you found this panel discussion informative and valuable. This webinar has been recorded and we will make it available soon on our Smart Manufacturing Experience website. And if you haven't already made your plans to attend the Smart Manufacturing Experience event June 7th through the 9th at the David L. Lawrence Convention Center in Pittsburgh, now's the time to visit our website and register. The Smart Manufacturing Experience will feature high-quality technical conference, technology-rich manufacturing show floor, high-valued keynote and panel discussions, plus a whole lot more. Visit smartmanufacturingexperience.com for more information. And again, everyone, thank you very much for your time. We really appreciate it and have a great rest of your day. See you next month. Bye-bye.
Thanks.